Guten Tag. Welcome. Sorry, I did the first one in German. Welcome to our latest live event concerning the news on embedded academy content. We had the last event in end of May. And since then, we took a small break in June and have been releasing new e-learnings weekly since the beginning of July to ensure that you get all the new courses and all the new content during the important onboarding phase of new colleagues in September and October. So we're really proud of having released quite a lot of new content in the last weeks. And we introduced also 3 complete new courses on 3 different topics, which I will dive into a little bit to show you what we've done. First of all, I want to start with the web page itself to take you through this. If you open Embedded Academy, you have this page to get to the e-learning portfolio, because we also have some on-site trainings in Regensburg and also some online trainings. So here is the most important part is nevertheless the e-learning portfolio. You can get there here. Usually you are informed about new courses in this field. So these are the 3 courses I indicated. And here you can also access the e-learning portfolio. Before we go into the news page, short introduction on the courses. So we started beginning of July with a course on power electronics fundamentals, where you learn within 4 e-learnings all the necessary things you need to know about power electronics. We've been releasing battery and battery systems fundamentals, where we go into galvanic cell and then battery packs and also battery management system. And we started CRC, Cyclic Redundancy Check. Currently it's in German, but of course, as soon as we're finished and have released everything, we'll do a translation into English. So this will be coming quite soon, as the content is existing, as we've been designing this. It's just a matter of language and translation. If you click on this news, you get to our news page, where we always inform about the latest releases. So this is going also back further. Since the last event we did in May, we released since beginning of July quite a lot of new content. First release was Automotive Spice, the process on product release, SPL2, which I will show you a little bit more about. Then the next we released was Power Electronics Fundamentals, with an introduction into power electronics. And then the next part of it, so there are 4 e-learnings inside. The second e-learning was components of power electronics. This is considering especially the power switches like MOSFET. Then we introduced battery. So the first part, battery cell, as part of battery and battery system fundamentals. Also still in July and last of July, we added the battery system part, making this course with just 2 e-learnings complete. So there are 2 e-learnings and this course is complete. For the power electronics course, beginning of August, we add the half bridge applied for controlling an AC machine with all the switching process. Last week, we released the first e-learning and started a new course on Cyclic Redundancy Check CRC, which will grow within the next weeks and will translate. So you can, more or less it will be available, I would say, latest by end of October. We will have all the parts released also in English, doing step by step. So whenever you want to know about what's new, of course, there's lots of information also in social media. For example, on the Instagram account, we provide the new information on a regular basis, but also here you find the news and you can scroll back and see which courses have been released when. This especially thank you for our customers who've been staying with us since 2-3 years when we started already and are continuously booking the full year access. For you, it's that okay, I had not time since, for example, before the holidays, it was really stressful, and now I want to know what has been newly released since beginning of July. Then there's the chance to get this information and to have an understanding on which topics we worked on and what have we've been releasing. In general, if there are courses in German, we will always translate into English. So some courses are only available in English, but every course which is available in German will be translated into English within some weeks after releasing the German one. So we will not have a big gap in between. So scrolling back down, starting with the first one, Automotive Spice product release. So we're looking at this process reference model of Automotive Spice, and the product release is SPL2. By now we covered it's one course where we have supply acquisition and supply together. So we have ACQ4 and SPL2 in this one course. We have a course on engineering, so we're covering all the engineering processes. We are covering the supporting processes which are part of the VDA scope. Not all of them, but the VDA scope is fully covered. And for the management process group, we have so far only project management, but IT security is in work, and also the measurement will be done soon. And this way, we are going to cover not only the VDA scope, but also all the processes which will still be there in ASPICE version 4.0, because not all the processes which are now in ASPICE version 3.1 will be covered in the future, or will be part of the process model in the future. So we put the focus on what will stay. And this means once we have covered these, we have covered all the processes which will be also in the upcoming standard. And of course, we are going to work on the 4.0 version soon. So this is the course on Automotive Spice, acquisition and supply. So we had the supplier monitoring there already, and now we added the product release. All ASPICE courses and e-learnings, or all e-learnings within the courses, have a similar structure. Usually we explain these, they have 4 different perspectives how to look at the topic. So you have the process purpose, which is always described. You have so-called process outcomes, what's the result of a process, and you have output work products. So outcomes and work products are not necessarily the same, yeah? which sometimes is a little difficult to understand, but the outcomes is this and this and this is fulfilled, and the output work products is I have this release information, I have really certain defined work products which are created, and to achieve the process outcomes you have best practices you are implementing. And so the structure here is always the same. In this case, the product release is not big. Yeah, there are other processes which have more content, but this one is not so big. So if you click on here or you go scroll down here, you get to the next points. So here is process purpose, then process outcomes, then the base practices are here, and the output work products you find here. And we just look at some of the topics, not all of them. For example, the process outcomes. Yeah?
Now that we have identified the process purpose of product release, we can look more closely at the intended process outcomes. The process outcomes define the expected result when product release is performed correctly. First of all, the contents of the product release are determined. After that, the release is assembled from configured items. Also, the documentation of the release is defined and produced. In addition to that, the release delivery mechanism and media are determined. The approval of the release can only take place against defined criteria. The product release is provided to the intended customer. And last but not least, the confirmation of the release is obtained. In the next step, we will take a look at how these project results can be achieved.
So the next step, like how these can be achieved, are the base practices. There are here it's more content. This is why it's split via 3 pages. And then as a result, you have the output work products. There I want to go.
Products arise within the framework of product release. First of all, a release plan must be drawn up which contains a rough schedule of the release and the necessary activities. All information about the release must also be carefully documented and stored. The product release package includes and associates the release elements such as software or the associated customer documentation. If there is a problem with the release, a temporary solution.
So here you have a connection between the work products and how they are achieved. Yeah. So, and here you can click.
The contents of the product release are determined.
So here are the process outcomes, like how it was indicated there, and you can get a connection between the process outcome and the work product by clicking on this. This connection exists, and now we are in this topic product release, and the output work products are defined or explained in more detail in a different chapter within this part. Yeah, and there I want to go also into the output work products to show you another connection, because these connections are important. Yeah. For example, here it's not just the release plan, but it's explained the release plan is only available in product release. But you have other content, like product release is maybe not the best example for this, but especially in engineering parts, you have work products which are exist in system and in software engineering, or which are produced in the design phase, are needed in a testing phase. So there are several work products which are important and contribute to different processes within the whole framework. And this is why we are indicating the process in connection to the work product. Yeah. And at the end, it's explained, and then we make the picture smaller so that you still see, the way in the process, and it's explained here. So this is, in general, the explanation on how Automotive SPICE e-learnings are designed and provided. Especially these connections between base practices, between process outcomes and work products, and the work products within the whole process framework, is important to get a feeling and an understanding how this process landscape is designed. So for now, I would say this is enough. Going back to the news, this was Automotive SPICE product release. Now we look in power electronics fundamentals, and there we are releasing step by step. So we released the first introduction. We released the components of power electronics and the half bridge, and now it's thermal assembly and design, which is currently in release phase. So I saw that some part is already on the web page and some part not. So this will be released today. So we have a look at power electronics, and I will close the windows I don't need anymore to get a better overview. So this is the introduction to power electronics.
Welcome to our e-learning basics of power electronics. This e-learning serves as an overall introduction to the entire power electronics fundamentals course. Click on Start e-learning to begin now. The goal of the complete course Power Electronics Fundamentals is that you become familiar with the topic of power electronics. Hence, you should gain an understanding of the fundamentals of electronics and some knowledge on important electronic components, in particular of the half bridge. This will be rounded off by an explanation of assembly and thermal behavior. In order to fully understand the contents of this course, you should have some fundamental knowledge of physics, electricity, and electronics.
So this was the introduction, and now a short look into the course. Like I said, here you already have 4 parts which are available, and the website is currently being updated because we're releasing it. And this is the description of the e-learning course, Power Electronics Fundamentals. So first we start with the basics of power electronics, definition, application fields, and basic functions. Then the electronic switch and switching in general, electronic circuit example, including the basic components with resistor, inductor, capacitor, and also a diode. Then we have to look, of course, into the components of power electronics to understand the semiconductor basics, semiconductor components with their switching capabilities for the diode and switchable power semiconductors. And then we have the MOSFET, 4 types, functionality, characteristic lines. What's upcoming and will be towards the end of the year, we'll do also an update with IGBT in more detail. This is also planned. Then we have the explanation of the half bridge applied for with the switching from DC to AC to control an electrical machine, with step-down conversion, step-up conversion, then the representation, and then the applications in the automotive field to have like a concrete example. It's the background know-how, how it's designed and how it's working, but also the concrete application. And the last part, it's not yet in the description, but here in Expand you will see it's thermal design and assembly with this thermal design and also some application examples. So this is the new course. And in general, courses are described like this. You have a content described here. You have a timeline described here. So the duration is just the time to click through, but this will not enable you to take in all the knowledge and so on. So what we recommend is to plan the time for learning, which is indicated here as study time. So if a new will be added, it will be some more time. So you should plan for this e-learning course on power electronics fundamentals to spend, I would say, 1.5 days. It's useful. We always have a target short described on who should learn it and what's the target, what you know after this. We always have a trailer, which is available on YouTube. There's also a full playlist, including all the different trailers. It's a good possibility to take a sneak peek into what's provided. And there are some insights where you see pictures of the e-learnings that you can imagine what is inside from a conceptual point of view. And then this part will look different. I can click now because I'm signed in, but if you don't have a subscription for the Embedded Academy, then you may not click on the courses here. Yeah, but nevertheless, you will see it. But this is the navigation for all the people who are signed in to navigate through the courses. And in the lower part, we also have an explanation on some points, what's power electronics, or what is the topic which we are explaining. In this case, what are power electronics, what are power electronics needed for, how are power electronics related to embedded systems, why this question, because we are Embedded Academy, and more or less everything we are doing has a connection to embedded systems. Even the most technology-based topics, because you have to understand the components and the technology behind in order to do electronics and software development for controlling them. Yeah. And then in the last part, what you can learn from this. So this is the new course, Power Electronics Fundamentals, with 4 e-learnings. And we'll just have a short sneak peek into some of the part. For example, here in the first part of Basics of Power Electronics, we have application fields and functions.
Many fields where electrical energy is required in various forms and with different voltages and currents. Here we name a few of many application fields. For example, it is relevant for the DC power supply of electrical appliances such as mobile phones, computers, and monitors. It is also important for the electric motor control of washing machines, electrified power trains, elevators, or drilling machines. Power electronics are inverter for solar and wind power systems.
So this is an example.
When talking about power electronics, there are 4 main functions. Each of these functions stands for a different type of converter. In general, converters adapt the electrical output in voltage, frequency, the number of output phases, or the polarity of the voltage. On the left side, we have the parameters in AC and on the right in DC. Click on the 4 arrows to learn about the converters.
So this is a basic introduction so that you have an understanding, okay, you can change from AC to DC, from DC to DC, from DC to AC, from AC to AC, and there the different converters are named differently.
Here, we talk about alternating current to direct current conversion, so AC to DC. We call this rectification. A simple example for this is the power supply for any of your mobile devices, which are powered from a battery. Hereby, you will transform AC power to a DC sink.
And DC to DC?
Conversion is DC to DC conversion. Hence, we speak of direct current conversion. For an example, you can think of a power bank for your mobile phone. A direct current conversion provides the possibility to store the energy within the power bank with a higher voltage than the voltage which is required in the mobile phone. This conversion is DC to AC, which we call an inversion. The typical example for this type of conversion are solar panels. They provide a DC current. To feed the energy back into the normal power grid, the energy must be provided as alternating current.
So this is the use case which is needed often in solar industry, and what we see also later, for example, to control an AC machine. And then the last one is AC-AC.
There is the option for AC to AC conversion, which is consequently called alternating current conversion. For an example, we can think of a windmill. The energy is generated from the turbine of the windmill and is directly fed into the electric grid, which is an AC grid. Hence, we have an AC to AC conversion.
So this is, for example, just the introduction, but I would say it's a very good visualization on understanding the most important terms. Yeah, and then here we also have the components of power electronics as a next course. And I think this is also important to understand the components which you're using. And here I chose the example of a diode, which I will show now.
Current can flow. This is called forward bias. The positive
I
side
have
of
to
the source
call
is connected
again.
to the anode and the negative side to the cathode.
Sorry, because it was part of it was already via interaction here.
The diode controls the current flow in a circuit. Here you can see the electronic symbol. It is usually made of a semiconductor, such as silicon. We have already learned in the previous chapter in more detail how semiconductors work. To explain the functionality of the diode, let's roughly repeat this again. It consists of two areas, P-type and N-type doped. These regions are created by adding other materials in each case. P-type means that there are too few electrons in total. The connection layer is called anode. N-type means that there are too many electrons. The connection is called cathode. The difference of electrons creates the so-called depletion region in the center. The electrons and holes where electrons are missing are attracted to each other. This generates an electric field that functions like a barrier. Next, we connect a voltage source. To see how the diode acts like a conductor or as an insulator, click on the two rectangles.
So this is also important in terms of didactics, not the content. Yeah, we had a quite long explanation with symbol and how it's working to understand this depletion region. And now, for one hand, you have a break, and you can decide if you want to learn more about the conductor first or the insulator, and then you have some interactivity clicking here on the conductor.
This is called forward bias. The positive side of the source is connected to the anode and the negative side to the cathode. As soon as the current is above 0.7 volts, the inner electric field is cancelled out by the outer one. This allows the electrons to flow freely.
So, and we also look at the insulator.
This is called reverse bias. Here the negative side of the source is connected to the anode and the positive side to the cathode. This makes the barrier even larger and no current can flow.
So I will not show everything. I'll skip the half bridge and I will look into a thermal design, and there I chose the heating part. Yeah. So start again.
We depicted the passive heating by the cooling medium.
I have to restart again.
We depicted the passive heating by the cooling medium.
I have to
we
go back.
This chapter, we first have to consider where heating actually takes place. First, we have an active heating of the device by the device losses. Hence, we have to consider the losses of the components themselves. But we also have the heating of the component by the cooling medium. This means there's actually a passive heating of the component. Taking both of these heating aspects into account leads us to a maximum temperature of the component. We want to illustrate this in a diagram. The axes express the time and the junction temperature, which is the temperature in the active layer of the semiconductor element, meaning the layer in which heat is produced. Based on the materials used here, a certain maximum temperature is already given, here indicated in red. Click on the numbers 1 and 2 to see the graphs of the active and passive heating. When talking about thermal design, we have to be aware of the thermal cycles of the component when driving this component. The thermal cycle describes the cyclic changes between two temperature extremes, usually happening at relatively high rates. Via the thermal cycle, it is possible to determine, for instance, product reliability. In our diagram, we find thermal cycles, for instance, here. In green, we see the active heating by the electric load. In orange, we depicted the passive heating by the cooling medium.
So I was late in because it was said click on and I didn't click on. So it's the explanation and clicking on, and then you see the active heating and you see the passive heating and the connection between the two. So this is also some interaction again. So we'll have here all the power electronics with 4 e-learnings, which is quite a lot. And as I said, you should plan 1.5 days to learn everything. So I can give you only a short sneak peek in what we did. The next topic, going back here, was the release of battery with the battery unit and also the battery system. Both we released in July, so this course is already complete. And then we also have a look into the course. Yeah? I like the introduction very much, so this is why we start with the introduction here also.
Welcome to our e-learning on the battery system as part of the course Battery and Battery System.
Have to start again. No, this was the wrong one. For the battery cell, the introduction is so nice. So I have to go to a battery cell for this. For the first course, the introduction.
Welcome to our e-learning on the battery cell as part of the course Battery and Battery System Fundamentals. Click on.
Okay, on the battery cell, I will just show you a short part on the galvanic cell. So it's starting with the galvanic cell and explaining it in general with functionality, but of course you need to understand also the equations, so we cannot skip these. But I will give you a short sneak peek into functionality here.
A galvanic cell is composed of 2 half cells, which are given by 2 beakers. In each beaker, there is a piece of material, for example a metal, that acts as an electrode. An electrode is an electrical conductor and is in contact with a non-metallic element of the circuit. Here, the electrodes are in contact with an electrolyte solution. An electrolyte solution is an ionically conducting solution. In our context, the electrolyte solution contains ions of the same metal of which the electrode is made out of. The materials used in this example for the electrodes are zinc and copper, which we already reflect in the colors. More generally, we can say that the electrode on the left is made out of ignoble metal, while the electrode on the right is made out of noble metal. When the zinc electrode is immersed into the electrolyte solution, it comes to a reaction between the metal atoms and the water of the electrolyte solution. This reaction is called oxidation, and it describes how the zinc atoms lose electrons. Thereby, the electrons stay in the metal, while positive zinc ions are dissolved in the electrolyte solution. This results in a positively charged solution and a negatively charged electrode. Hence, the zinc electrode is the negative pole of the battery, and it is called the anode, as it is the electrode which accepts electrons into the circuit. Respectively, the copper electrode will be the positive pole of the battery. It is called cathode because it donates electrons, which are leaving the circuit. Now we connect the anode with the cathode through a wire. We insert an ampere meter to see when current is flowing. Alternatively, we could also use a light bulb. The electrons that accumulated at the anode can now flow to the cathode. This results in free electrons in the cathode. Thereby, they enable the second important chemical reaction to take place. This one is called reduction. It describes how the copper ions in the electrolyte solution accept the free electrons in the cathode. Thereby, they form copper atoms, which are bonded to the cathode and leaving a negatively charged electrolyte solution. So, keep in mind, oxidation happens at the anode, and here the metal atoms lose electrons. The reduction takes place at the cathode, and here the metal ions gain electrons. We say the ignoble metal is oxidized, while noble metal is reduced. Note that the oxidation and the reduction are the two chemical reactions we are interested in, as they provide the energy in the end. However,
so I'll stop here. This is going into functionality on understanding how the process is working. And the second part I would like to go into is the Ragone plot. Yeah. The Ragone plot is showing energy versus power and is giving you an indication on which battery type is the right one on your application. So everybody who's working in battery knows the Ragone plot.
There are different energy storage systems. They can be compared in a Ragone plot, where they are compared with respect to specific power and specific energy, which we call the key parameters. It is important to remember that specific energy and power can vary within the same technology, meaning that even with the same cell chemistry, the design of the cell can be created for high power or for high energy, for instance, due to different particle sizes or layer thicknesses of electrodes. Usually, cells can be designed for high power or for high energy. Unfortunately, both power values cannot be optimized independently. A design for high power results in less energy and vice versa. This also holds for the operation of a specific cell. Operating it at high power utilizes less energy and vice versa. More information on this topic can be found via the red button.
So there's additional information, and in the next slide or page,
now let us compare the different energies.
It's the comparison, and where you all have these buttons, you can click and then you get additional information to certain cell types. Yeah.
Storage systems, respectively, the different battery types. Click on the different terms to learn about them.
Okay. Seems like we have a problem with here. I have to click here.
Lithium-ion was very expensive, and hence nobody considered using lithium-ion batteries in large-scale automotive applications. But all in all, lithium-ion batteries provide a better energy density and cost reduction in the long term. Dozens of materials were developed and established lithium-ion batteries as the highest class of batteries, starting between 100 and 200 watt-hours per kilogram.
So you get different information for the different battery types, for example here.
Historically, lead-acid batteries were the first mass-produced secondary batteries. Secondary batteries are batteries which are rechargeable. At the end of the 19th century, they were used for electric vehicles. Still today, they are often used in 48-volt transceiver stations for telecommunication or forklifts. And they still have a huge market as 12-volt and 24-volt starter batteries for cars with combustion engines. The energy density is very low.
Okay, and then this course provides you also with a battery system example with some information on battery safety and then battery management system.
In batteries is a lot of electrical and chemical energy. This energy is compressed in a small volume. Therefore, safety is a concern that has to be satisfied under all conditions.
So here are the different aspects which are to be considered for safety. I will just take the next one, overcharge, and then we go to the cyclic redundancy check.
For the operation of the battery, the cell voltage, the temperature and the current are relevant factors. The voltage and temperature impact can be shown in a two-dimensional image. First, overcharging above the cutoff voltage can cause lithium plating on the anode. The occupied graphite can't intercalate more lithium, and so short circuits by dendrite formation are possible. Above around 6 volt, the cathode material becomes unstable by complete depletion of lithium. Collapse of the grid structure can then lead to a temperature rise and a release of gas and fire.
So the different safety aspects are, the risks are named and explained, and then of course it's explained how to ensure that you have safe operation. So this, I would say, for now, for today, on what's new on battery and battery system fundamentals. And then I would go, even though it's in German, to the cyclic redundancy check. This course is composed of meaning of CRC, then where it's applied, the CRC, different lengths, then the principles, like how does it work, the polynomial, and the generator polynomial. And then there is an example showing a CRC5, so that you really have an example on how the CRC is working. So the problem is that this is in German, yeah. So this is how it's working. So it's explained that you have a data and you're generating the CRC, yeah. And for example, one of the examples where it's used is if you are have a serial bus protocol, like for example CAN, FlashArray, or Ethernet. All of them have a CRC defined, so that the sender is calculating the CRC, and the receiver can recalculate it and to find out was the data transmitted correctly. So this is one use case. And here then the different parameters I explained, like the generator polynomial, yeah. And it's kind of a key which is defined, and both sides need it, because otherwise they will not know the calculation method. Yeah? Like I said, this is the first e-learning which we just released. We'll have more on here. The example is CRC5, yeah. But there will be more like CRC8 and 16, and we're going to translate as soon as we are finished with the course. We are going to translate into English and to release this too. So it will be released by latest end of October. So this is from my side, all the news we had. So looking back, we had a new release on automotive spice, power electronics, battery system, and cyclic redundancy check. We introduced 3 new courses within 2 months, which is a lot of new content. We are working on more content. We're also happy to receive feedback from you, what you would like to know in addition, because we're working on the future roadmap and are adjusting depending on customer needs, of course. We'll have an update on what's new about every other month. Next time might be a little bit sooner, maybe even end of September or beginning of October. And then I don't know if in December we'll have it before Christmas or we'll go into January. This depends also on how much there is, which we are really proud of to show you. So if there are no questions, I would close the session for today. So thank you very much for taking your time and for your interest in the Embedded Academy. And I'm happy if you're checking the news page on a regular basis. Thank you for your time and have a nice day. Bye-bye.